All right, so as I've mentioned earlier on, we need to be able to separate the train, validation, and test set, right? So I've just put some notes, which basically say that whenever you're building a neural network, you should never test a model with the data that it has seen on training, right? Otherwise, we won't be able to see if our model is memorizing or it's validating well, or its validation accuracy is correct, right? So we need to be able to separate these three data sets. So in order for us, so like what I've mentioned before, we need to be able to separate because we already have the test set, right? But we don't have the validation set. So from the validation set, I'm simply going to extract it from our train data set, right? So I'm simply going to use a train test split function from the sklearn library, right? So what I'm simply going to do here is I'm simply going to extract it like this. So I'm simply going to paste this code and I'll explain it. So what it does here is we are simply using this train test split, right? So what we are passing here is we are passing the training data. So remember, we want to extract 10% of our training samples. Then we pass the one hot encoded labels for our training dataset, the one that we have encoded here, the zeros and ones. So we're simply going to pass them in this function. Then we say the test size that you want to extract from this is going to be 10% of this dataset. And then the random is going to be 42. It's just going to randomize the data, right? So that we don't have some sort of like a sequence or flow. We're just going to randomize the data. So here is just an arbitrary number that we can just choose. So in this case, once we have split this data set, you remain, this function will return the X train data. So this X train, this is now our new training data set. X validation, this is our new validation data. Then the Y train, these are now our new labels, right? So remember we had the label called one hot encoded, no longer named this. It's now called Y train. So here what we simply have, we have our training labels and our validation labels, right? So what we've extracted here is we've extracted the training data, right? Comma validation, right? And then train labels, and then validation labels. So this is what we've done. So we've simply extracted this. So I'll simply run it. So you extract it from the training data and your labels. So this train test function is a really handy function that will be able to separate this for you. So you don't need to do some hard coding to do this. You can just use this function to do that for us. So once you have done this, you can simply go ahead and look at it again. You can look at the head. It's still a data frame. It's still a two-dimensional tensor. Nothing has changed, right? Only the variables have been changed, and also the number of records have changed, because it's no longer 45,000 in this case. I think it's now around 40,000, less the 10% of this, which is around 4,000, I think. So we have separated the training data and our validation data. So this is now what we have. So once we have separated this, I can simply print. Let's simply print the train shape so that you see what I mean. So if I say X train, nothing has changed here. It's still a 2D tensor, but maybe of course the validation data, of course the data is no longer it's no longer 45,000 because we have split a percentage of it. So here our training data is no longer 45,000, it's now 40,000. Then the rest of the data, it went to the validation data, which is 4,000. So I simply extracted 10% of this data and then it came here. But the rest of the data is still a two-dimensional tensor. Nothing has changed, right? So if I can check the dimension of our data, so here is still a two-dimensional tensor. So here I can say dot ndim, right? So which means it's to a vector. Nothing has changed, right? So in the next segment, we will be building our first neural network. I'll see you in the next one.